Thank you very much, and welcome. So we're talking about today. We're talking about the surface texture as a critical part of geometrical tolerancing. And my name is Stefan Rosén, and I come from Amsterdam, where I run the company Toponova since 1994. And from the beginning, it's been surface and surface metrology has always been the key business to us. I'm also a member of the ISO committee and here in Sweden. And as told before, so far more than 2,000 projects for this within surface texture. And basically, it's what is working, why it's not working, what is the link between the function and the surface texture, and especially what should be put on the drawing to really assure the quality of the to assure the surface quality. So this is one point to see it, that poor quality costs a lot of money today, and surface texture and geometrical tolerance is one part of it. If we don't have the correct specification on the drawing, we will get samples that are not up to the quality required, and we have to, of course, scrap it. And what we're facing is that even how we do it, every manufacturing creates geometrical deviations, and that is those deviations or the deviations that affects the quality of the workpiece. And of course, geometrical deviations can be large and small. And these deviations create that you have different shapes, different form, and of course you can also have very different surface texture if you have not made it the same way. And it's often these geometrical deviations that make the product look, feel different, in the worst case not even work as intended. Therefore, geometrical deviations must be controlled and to ensure functional and quality requirements. And this is what we do on a specification or in a drawing. So when designing a product, the designer draw a nominal model of the product, and in this model there is a perfect geometry and the surface is perfect. Or not perfect, it's smooth. And this model must also be controlled in terms of geometrical deviation. So the designer here has tolerances to the critical dimensions on the workpiece. And the geometrical deviations are important because it's in this, with the tolerances, the designer limits how big the deviations can be and still make the workpiece work. And in ISO, there is a system for how to put tolerances on a drawing specification. And that is called in the ISO geometrical tolerancing, or ISO GPS. And one of the piece, or one of the characteristics that is we see, especially from my side, since I'm working with it, is that very often we have quality issues, and it's regarding to the surface quality. Here it's very obvious that we have a haze and we have a very glossy surface, but sometimes you're in between. And then comes the case, how should we really specify the surface texture onto this? Because in many cases, it plays have a huge impact on the functionality of the product. It can be visually, but it can also be mechanical. So anyhow, when we talk about surface, it's the outermost layer of the workpiece, and it's also inside. And the deviations on the surface, of course, a result of how you did the manufacturing and the material you used. So when we're looking on surface texture or surfaces, it's deviations we're looking. And surfaces are often designed with both with intent, and then the designer must consider these surface deviations and how to control them when he put the sign on the drawing. And how do we control that surface on the drawing? Then we use symbols, and the terminology for us is surface texture. And surface texture is the deviations in the surface after removing the nominal form from the form of the object. And workpieces very often have many surfaces with different requirements, and they must be specially specified individually. And as you see on the example here, do we have a pointer? Yes. Not working. Okay, so here is a symbol for surface texture. And on a drawing, you are able to specify surface texture in detail. And there is a symbol in the ISO GPS. There are two symbols, basically, how to specify surface texture. And this is a way for a designer to control the surface texture on the drawing using the symbol for surface texture. So with a complete specification of product geometry, manufacturing can then communicate and control the correct product quality and avoid surprises. So if you have done the specification correctly and you specify the functional deviations of the surface, then you should have less problems when communicating the quality between manufacturers, different suppliers, etc. And in the end, the goal is that we have products with the same quality. So, luckily, there is a toolbox for how to specify and communicate geometry of products on technical drawings. And it's done using an international symbolic language called the ISO GPS. So example of one drawing where you have symbols indicating different things for geometry. And also here you see one example of how to put surface texture onto the drawing. And the ISO system for geometric tolerance, as I said, it's ISO GPS. And specification of geometrical specification and verification. And well, before it's been working for a long time. It's more than 30 years experience into this. And there's now one committee working with this. And this is TC 213 that is responsible for the GPS. And in the ISO GPS, we also have a framework for specifying and verifying product geometry on a drawing. And of course, the first step is that we have a idea. We should do a product and we should have some kind of design intent. Why are we doing this? And then, of course, we have to specify or be sure about what is the function of what you are designing. because it's up to the designer to translate what is a functional surface and what are the requirements. And it is surface deviations that we have to put into the specification, because we need the specification to communicate to the manufacturer. Manufacturer conducts and manufacture this according to the workpiece according to specification. And then you got the workpiece, and then you have the quality control that make the measurements and analyze the measurement results. And then we do the comparison of the workpiece according to the specification. So this is a basic workflow today. And of course, we often see that the function is the biggest problem today. What are the really functional properties of the surface? And how do we express it on the drawing? The framework consists of standards related to the specification and verification, but also how to compare the specified drawing and the measurement report. And to organize the standards, there is a matrix of 7 chain links used, and you can see here that we have standards here for A, B, and C. That is more for the specification. So A is more how is a symbol looking like? How should it look like? And how should we put in parameters into the symbol to be readable? What are the parameters you find under the B? And C is what are the properties of the parameters. And then on the E, F, and G, you have standards correlating to the measurement and quality. And D is for quality acceptance. And surface texture have a complete toolbox with standards covering everything from how to put it on a drawing. We have 2 symbols today, one for profile measurement, profile surface texture, and aerial surface texture. So as soon as you see this symbol, you have full standard support. How to put it on the drawing, what parameters to use, what are the properties of filters, parameters, how should we measure it, what kind of equipment can we use, and how do we calibrate the instrument. So for us, working with surface texture, if we know what is specified, it's not a black box. We just follow the standards. But the thing is to know what are we going to specify? What are the functional properties of the surface? That is a key trick, because when we have finalized that one, then everything is more or less automatic in this, because here we are a lot of parameters. We have a complete toolbox. For curiosity, we can say this is how the old standard looked, and this is withdrawn in December in 2021. And as you can see now, there were a lot of standards before. You have to keep a track of all of this to really understand how to make the drawing, and also how to interpret the drawing symbol to do the correct measurement. But this was also made in 97. Before 97, Germany, Sweden, Japan, everyone had their own standards. And this is what they said in 97. Okay, now we put everything in one box, called it ISO. And this is now the result of all these years of work. And now it's compiled to a more nicely toolbox. So the big, the big thing, or the new things in our area, is that we now have a new symbol for profile surface texture. The new standards are called 21920. And going back, so important for us is what is a symbol? Because the symbol tells us what is a toolbox to use when we are measuring and specifying the surface texture. Area is also existing, and that is 25178. And it's a ROM that tells us it's a aerial standard. The most important change, well, if you're not into surface texture, it's not so big, but for us it's big. Because here we had, in the past, we had a big uncertainty factor, and that was verification. And in the new ISO standard, when you are doing the measurements, the default settings are given by the value on the drawing. And that makes it very, that is sure that when we come to the verification, people know, or the operators know, how to select the measurement. And it's very clear, you have a procedure, you have tables following up. In this case, we have upper limit, it's 0.6. Then you go into the table 3 in this, and we see RA 01 to 2, and then you have all the settings. So then it's not a black box for the operator. It's just to read and do. But in the past, it was a big problem, and it still is that basically when you measure roughness, it's not the roughness value indicator on the drawing that gives you the info how to do the measurement. It's a surface itself that gives you indication how to measure it. So you have to measure it, and then you have to find out what should the settings be. And that is a little bit messy today, especially if you are in the borderline between two settings. And we also see that even in one factory, they can do it differently, depending on the operator. So this has caused a lot of confusion and uncertainty for verification.
Can you switch back? One more. Good picture.
Back.
Yeah.
You will have a printout.
Like it here.
But this is one. There are many tables. Secondly, important change is that also the different tolerance acceptance. That was a long one. Tolerance acceptance rule is changed to what everyone thought it was in the past. So if you have a RA 0.3, it is at that is a max limit, but it can be as smooth as possible. But in the old times, in the old standard, we had something, the default line was 16% rule. So it meant that if you did one measurement, that should not be 0.3, it should be 70% of the given value. And this is, in practice, you see this when you have a discussion between the supplier and the manufacturer. Because if you're looking on the drawing and you say, okay, I have here 0.3, and then you say, oh, it's not according to the specification. So please give it down. So this has also been confusion because no one really know about this rule. And but when you were in conflict and it was expensive part, this rule applies. Then it can make a big impact if you're a supplier. So
What was the point of that rule?
it's that we have a surface texture itself has a huge deviation internal. So if you measure on one place and you measure on another place, you have a deviation. And to compensate for that, we have this 16% rule. In normally it means that you make 3 measurements, and then none of them should be above 0.3. But it could be expensive if you didn't know about this, and because that when you were into purchase and discussions, and you have reclamations, this could be costly. So with the ISO GPS toolbox, manufacturing have access to standardized tool, and there is no black box. It's quite clear, but the question is to know the box and how to use the tools, because it's a very well documented system, and you have standardization from specification to verification. So, any questions? No.
But in my old school days, I remember we had a reference surface, trying to decide where we actually ended up in this.
Yeah.
Is this still the method, or is there still a quicker method? Or
The designers are using that,
yeah,
just to get the feeling for perception maybe. But it gives you an idea. But for would say surface is not that important. It's okay. But if you really have a functional demand, it should be glossy, it should be haze, it should have tribology, not wear, low friction. Then you have to express surfaces in different ways.
right. But it's still, the measurement. Then you need to go to a microscopic measurement or something like that.
Yes, we still have we have a lot of different measurement instruments, optical and tactile. But we don't use a finger to specify the rule, to verify the rule. Yes?
Was visual inspection play a role, and if so, is it included in the framework?
Sorry there.
Does visual inspection play a role, and is it included in the standardization and measurement framework?
No, we do measurements, and all the measurements are either optical or tactile.
Does it mean?
But we have there is one surface lay. We can specify surface lay, and that is done by optical method. You have to define that you have circular or linear marks or something. But there is no metrology specified.
It's just about to spread knowledge about the new way of doing it.
Yes, yes. Yeah, and as I said in the beginning, I see lots of quality issues today. Is you don't have you're using RA and you don't using the toolbox completely.
I have a question. In the old standard, which is cutting with gold, were there a difference between if there was a profile measure or an area measure?
Yes, and it still is.
Okay, but even in the old, because you use the same symbol, and I think that could actually be.
Yeah, no.
confusing
So
what we need.
no, so 3D has always been that one. You can never have a 3D for that one. But that is common, I've seen. And this is due to that people are not aware of how it works. And for us, especially for me, if I'm in the measurement room, I look at what they are the symbols, because then I know this is a profile. Now I'm in the profile section in the lab. But of course, you have the uncertainty in the specification if you specify it wrongly, because then you don't know how really you should verify it. And that causes a lot of confusion today. Yep.
If you have a model drawing, can you still use the symbol or?
Yeah, it's not a law, so it's. But then it's also that all the standards, old standards apply to that one. You can't mix a new standards into the new one. Then you should also measure the old way. But of course, there will always be a lot of drawings with the old symbol. But then it's important. Then we know what are the standards correlating to that specification?
Yes,
Yes.
I have the feeling that it becomes much more complicated than before, or much more complex. There are many different standards that you need to relate to. Of course, it's now well organized, but still, I think you need to know a lot if you would like to read the drawing now. So, is there any, let's say, way to, or any education for the engineers ongoing in this area? Do you have connections to universities? Are you aware of any professors that are taking this into consideration?
There are
No. Maybe a question to the audience, if there is someone from academia here, are you aware of that this is part of the education? Because I think it's really the basic knowledge that the engineers need to know when they come to our companies. To read a drawing, to know how the surface texture is measured.
At more advanced levels, research level, there are professors working with this for sure. Maybe Rosén, for instance, and others. That we measure or after engineering, I don't know. Somebody else has done.
not for general, because it's not been, there have been some customers that really putting effort into it.
But it's not only about this surface texture, it's about the whole ISO GPS system, it's a lot of knowledge.
And thank God, that's why I'm here.
Actually, I remember when I was a PhD student, I had a guest lecture. But I was a PhD student within this area. I had a guest lecture at Chalmers for the engineering students regarding aerial surfaces.
Yeah.
That was for I think, a design course or.
Well, I can tell you, the main job for me is when I first get the troubleshooting project, I first start with the education. Let's sort it out now. What's wrong here? Is it specification or verification? And normally, as you and me discuss, what are the functions?
I mean, we had some internal discussion about this question in general, that back in the days when I started studying mechanical or the drawing and so on, this was part of the basic education. Second term, every student had to learn that, maybe under some other standards, and we have the feeling that this is now disappearing a bit from the curriculum. But maybe we just not have the right picture.
There will probably be more ICDFS today.
I agree with you. It's always about to understand the function. That's the start.
Yes,
If
exactly.
you don't understand that, it's
No, and then it does, because if you do that, then you have the tool, then it's quite easy.
Gentlemen, thank you very much, Stefan,
But we
for.
will take it after.
Yeah, I was supposed to say that. We can continue the discussion afterwards because a couple of more talks and speaks will come. But Stefan, thank you very much for a very.
Thank you very much.
interesting, yes, so now it's time for Rickard. Doctor